In this video, we're gonna learn how to find the trigonometric function values of any angle. So there's a special class of angles which are multiples of 30, 45, or 60 degrees, or in radian it is pi over 6, pi over 4, or pi over 3. So if any angle is a multiple of any of those, then we can find the exact value of those angle using the method discussed here. um, so after we learn that, we can find angles such as the values such as cosine 120, sine 3 pi over 4, tan negative 7 pi over 6, and cosecant negative 240, cosine 2 pi 25 pi over 3, or cosecant 760. These are like some examples that you can do after we learn the method here. So before we do that, there's only one formula that we use. So the formula is t theta equal plus or minus t, the reference angle. So we normally call theta r for the reference angle. So this is the only formula we use to find any of those angles, any of those values. So we have two things here. So the first one is the sine. So you can see that there's a sine here. So this sine, we're going to use the ASTC argument to find the sine. So this A means all angles, all ratios, and S means the sine or cosecant. Cosecant is the reciprocal of sine, and then tan or cotangent, and then the cosecant, uh, uh, cosine or secant. So what this says that only these are positive, everything else is negative. Only these or their reciprocal are positive and everything else is negative. That's what the ASTC means. So that's going to give the sign. So, and then what is theta r? Theta r means the reference angle. So reference angle is always, so there's a relation, reference angle always an acute angle. So in degrees it is either 0 or less than 90 degrees. In radian it is either 0 or less than pi over 2. So that's the condition for the reference angle. It's always an acute angle. Now to find the values for the reference angle, we can use this common table. So we can use the table for those values. So we can use the table to find all of this. This is a common table. This is something you need to remember. And then you know that this is very easy to find those values. For example, you know, if you reverse the sine row, you get the cosine row. If you reverse the sine row, you get the cosine row. And then to get the tangent, what we're gonna do is we're gonna divide sine by cosine, and then you're gonna get the tangent row. So you can see that that's very clear. So to find the tangent value, you just divide the sine value by the cosine value. And also, when they are multiples of pi over 2, what we can use, we can use the unit circle for that. So that means to find those two columns, we can use the unit circle just for those two, for last two columns. And then you can see that the sine value is just the y coordinate. Sine value is the y coordinate because the r is equal to 1 in this case. So the radius is equal to 1, so you can ignore that. So that means sine is just the y coordinate, cosine is just the x coordinate, and then to find the tangent, you just divide the y coordinate by x coordinate. So that's how you find the last two columns. So this can help you to find those two values. So that's it. So if you remember the table and the circle, you can find all those common values. And you can see that also tangent 90, which does not exist because you try to divide by 0. So dividing by 0 is not valid in mathematics. It doesn't have a meaning. That's why we say DNE. But sometimes there are certain practical problems. You can say that either it is plus infinity or minus infinity depending on what side you approach the angle. So those are the common things that we need. And also, for example, if you need to find the cosecant, what we normally do, we can find the sine and take the reciprocal of that. And then we can see that when we do solve problems. And also do the same thing with the secant. If you need the secant, take the reciprocal of cosine. If you need the cotangent, you take the reciprocal of tangent. So those are the common things that we need to remember. And also let's look at some special angle values. So we also know that if you measure an angle to the clockwise direction, so we call that is a positive angle. And if you measure an angle to the counterclockwise, if you measure the angle to the clockwise direction, we call that is a negative angle. So counterclockwise positive, clockwise negative. That's like a sign convention for in trigonometry. And also the straight angle. So when the straight angle, so that means the half a circle, so which we call pi radian, or 180 degrees. And if you go the complete cycle, which is 2 pi, or in degrees, which is 360. So those are the common things that you remember to find those values. And degrees. So in degrees, we have these common angles that we need later. So in degrees, we have, so we can start with a 0, and then so we have 180. So we can start with 0, and then we have 180, and then if you go if you complete the cycle, so you get 360. And if you add one more 180, so you're gonna get 540. And if you complete the cycle, so you're gonna get 720. And if you add one another half a circle, so you're gonna get 900 degrees. So these will be useful when you want to find the reference angle. And then in the radian, so we have a similar idea. So in radian, what we have is, so we can start with 0, and then we have pi, and then 2 pi, and then 3 pi, 4 pi, like that, 4 pi, and then so we have 5 pi. So you can just continue like that, but this will be very useful when we find the reference angles. Now let's discuss how to find the reference angle. So reference angle is the distance between the given angle and the angle on the x-axis. So the so we can write it like that. So we can say the reference angle. So reference angle is the difference. So that means always positive. Difference between the given angle that means the one we're going to find, the given angle, and the angle on the x-axis. This will be very clear once we talk about one or two examples. The angle on the x-axis. These are the angles on the x-axis that we just mentioned here, the degrees and radian. So so let's look at these in different cases. Let's find the reference angle for theta equals 60. So theta equals 60. So let's draw the angle first. This is in the first quadrant. So the angle is this one. So that is 60, and which is less than 90 degrees. So that means in this case the reference angle is equal to the angle itself. Now let's look at theta equal 120. Theta equal 120. So this angle is in the second quadrant. So let's draw it. So 120. So angle is given like that. So now what we're gonna do, we're gonna see what is the closest angle on the x-axis. So in this case you can see that the closest angle on the x-axis is the angle 180. So that means we're going to take the difference between those two angles, 180 and 120. So that means the reference angle is in this case is 60, because the difference between 180 and 120, which is 60. So that means in this case also the reference angle theta r is 60. So now let's look at theta equal 210. So 210, which is more than 180 and less than 270. So that means the angle is on the third quadrant. So that's the angle 210. And then again, the closest angle to this one is the x angle is 180. So now what we can do, we can again find the difference between the two, 210 and 180. You can see the difference is 30 degrees. So it's 30. So in this case, the reference angle is 30. So theta r is 30. So next, look at so theta equal, let's say 315. So let's draw the angle again, and you can see this is more than 270, less than 360. So that means the angle is on the fourth quadrant. So this is the angle. So this is 315. You can see the closest angle on the x-axis to that is 360 in this case. So it is 360. Now we're going to find the difference between 315 and 360. And you can see this is 45 degrees. So that means in this case the reference angle theta r is 45. Next, let's look at a negative angle. How about theta equal negative 240? So this is a negative angle. That means it's going to go clockwise direction. So it's going to go clockwise direction. So it is 240, which is more than 180. So that means it's going to go to second quadrant, because it's going to backward and go to second quadrant. So that means the so this angle is over there. So that's the angle we are talking about. This is negative 240. And then again, what is the closest angle on the x-axis? You can see it is negative 180 is the closest angle. So I'm going to draw that on this side. So this is negative 180. Now again, we're going to find the difference between the two, and you can see the difference is 60. So it's a positive value. It's always positive. So difference is 60. It's a difference. So it is 60. So in this case also the theta r is 60 degrees. And then finally, let's look at this one. So let's say theta equal 585. So when I say 585, so you can see that this is 360, more than 360. So that means if you subtract 360, you're going to get 225. So that means this angle is on the third quadrant. So this angle is on the third quadrant. So why is that? So it's going to start in the 0 position and go one cycle. This is 360 and another 225. So so that means the angle is there. It's the angle. So this is 225. This is actually not 225. This is a whole angle. So it is 585. 585. And then so what is the angle on the x-axis? And you can see in this case the angle on the x-axis is 540. That's why we talk about those angles. So now we're going to find the difference between 540 and 585. So you can see that that's again 45 degrees. That's the difference between the two. I mean, in this case the reference angle is also 45 degrees. So that's how you can find the reference angle on degrees. And you will see that right after we know this method, it's going to be very clear, and you can find any angle which are multiples of 30, 45, 60 in few seconds. Okay, so let's talk about how we do that in degrees, radians now. It is easy to find the reference angle when the angle is in radian. So it will be very clear when you look at few examples. So let's say the angle theta equal pi over 6. So let's draw the angle first. So which is in the first quadrant. So that's the angle. So and you can see that so since this is in the first quadrant, the reference angle is the angle itself. So the theta r is simply pi over 6 in this case. So let's look at a different one. So let's say theta equal 3 pi over 4. So I'm going to say that this is the reference angle, just this part. And let's see why. So let's draw the angle, and you can see uh, this is in the this is less than pi and more than pi over 2. So that means this angle is in the second quadrant. So the angle is in the second quadrant. So that's the angle. So we're going to find the reference angle. So, and then you can see that what we normally do is we can look at the multiples of the denominator. So that means in this case the denominator is 4, so it is 0, 4. And then why we do that? Then if you do that, then you can just compare the numerators. So in the numerator you have 3, now we have 4. That means the difference is only 1. So that means 1 of pi over 4. So that means it is simply pi over 4, because 1 of pi over 4 means pi over 4. So the reference angle is pi over 4. And I'm going to show you like another argument. So that means in this case you can see so the difference between the two is simply pi over 4. So so theta r, the reference angle is again, so it's pi over 4. And why? So again, what we're going to do, we're going to see the difference between the angle closest to that on the x-axis. So in this case the angle closest to that is pi, so that means we need to take the difference between pi and the angle given, which is 3 pi over 4. Now what we do, we can take the common denominator, and you can see that when you take the common denominator, which is 4, you can write 4 pi over 4. So we write 4 minus 3 pi over 4, and that is the reason why we consider multiples of 4. You can see that number is right there. That's why we want to consider multiples of 4, because that's the number, exact number goes there. Now you can see, since they have the common denominator, you can just subtract the 2, so you get 1 pi. So that's why pi over 4 in this case. But you can see we can use a shortcut. We can just look at the multiples and take the difference, and you get the answer. So let's look at one more and it will be clear. So let's say theta equal 4 pi over 3. So again, the claim is this is going to be the reference angle, and but let's see whether that's the case. So you can see this is in the third quadrant. So this angle is in the third quadrant because it's more than pi. Because if you have 3, which is pi, but this is 4, that means we go to the third quadrant. So which is in the third quadrant. So this is the angle. So which is 4 pi over 3. Now again we can look at the multiples of 3 now. So we have 3. Actually we can start with 0. So we can start with 0, and then the 3. So 3, but we have 4. So that means the gap is 1. So that means it's going to be again pi over 3. Again, if you look at the calculation, you can see in this case the angle is bigger, so we can do 4 pi over 3 minus the closest angle is pi, so subtract pi, and then we can write the common denominator as before. So in the common denominator 3, that's what this 3 means. So you're gonna write this one as 3 over 3 pi. And then you can see that, so it's a 4 pi minus 3 pi, which is pi, so pi over 3. So you can see again the reference angle you're gonna get for this one is theta r, which is pi over 3. So that's the reason. So when you are in radian, you can just look at the main factor here. So for the first one pi over 4, this one pi over 3, like that. Okay, let's look at 3 more. So how about theta equal so 11 pi over 6. So now you know what's the reference angle. So it's like that, but let's confirm. But later you will see that that's exactly the case. So 11 pi over 6. So let's look at multiples of 6. The denominators is a 0. We have 6, and then 12. This 11, that means it has to be on the fourth quadrant. So the angle is on the fourth quadrant. So that is 11 pi over 6. That's the benefit of just considering the multiples of the denominator. So 0, 6, 12. Since this is 11, it has to be there. Now again, we need to know the difference between the two, and then so you can see we can do a similar calculation. So it is 12. So that means we have 11. So you can write this one as, actually it is 2 pi minus 11 pi over 6. So to take the common denominator, we multiply by 6 both. So it's going to be 12 pi over 6 minus 11 pi over 6. And you can see that this is 1 pi over 6. So in this case, again, you're going to get theta r, which is simply pi over 6. Okay, so that's very clear. Why we have 0, 6, 12? Because 12 minus 11 is 1. Okay, so the next one is, so let's say we have a negative one. How about theta equal negative 5 pi over 4? So this is a negative angle. Since the negative angle is going to go clockwise direction, that's the first thing we notice. Clockwise direction, and it is more than 4, that means it's going to go to the second quadrant. It is in the second quadrant, so that is the angle we talk about. So this is negative 5 pi over 4. Now we can talk about multiples of 4 but negative, so it is start with you can say it is 0 and 4, like negative 4. So we have negative 5, negative 4, the gap is 1, so that means the difference between the two is simply pi over 4. So even though the angle is negative, the reference angle is always positive. So in this case, again, the same argument. So reference angle is simply this part. So it is theta r equal pi over 4. Still positive. Reference angle is always positive. So let's do one more. So how about this one? So let's say theta equal 31 pi over 6. The same argument, we already know what is the reference angle. Let's confirm that. You don't have to confirm, but I'm just telling you here why we do that. But when you have problems, you can just pick that one. It only works for pi over 3, pi over 4, and pi over 6 when the angle is in the simplified form. If it's not in the simplified form, it doesn't work. It has to be in the simplified form. There are no common factors. Okay, good. So let's see where this angle is. So we're going to look for multiples of the denominator. So we can start with 0. It's positive. So it is 0. So you can say, so it is 0. And then we have 6. And then 12. And then 18. And then 24. And then 30. So 31, that means it is on the third quadrant. So the angle is, so you're going to go, so it's going to go several cycles. So it start with 0, 6, 12, 18, 24, 30, 31. So that's the angle. So again we have 30, and then what we have is 31. The gap is 1. So that means, as before, theta r has to be only one such. So that means pi over 6. That's why it's always you can pick that part as the reference angle. Okay, now we know how to find the reference angle for even for the radian. So since we know the reference angle, how to find the reference angle, now we can actually look at several examples. So you can see that, and also one of the very important fact about these problems is, if the angles have the same terminal sides, they have the exact same ratios. So that means what we normally say, the coterminal angles have the same trigonometric function values. If the angles have the exact same ending, because we also always talk about the standard position, that means every angle start at the 0. That means if the ending value, ending side is the same, it doesn't matter whether it's a positive angle or negative angle, they have the exact same ratio. So let's look at two cases. So let's talk about this one. So for example, this angle negative 120, So if you talk about negative 120, like this angle, negative 120, and the positive 240, positive 240 have the exact same ratio, because those two angles have the exact same terminal side. Because just a ratio, we only talk about what is the y coordinate and what is the x coordinate. So you can see that both those two angles, even though one is a positive angle, one is a negative angle, and you can see this is a positive angle and this one is a negative angle, but they have the exact same terminal side. So that means all the ratios are the same. That's very important. And we can also look at one more like this. Um, for example, negative 300. Negative 300 means it's going to go to the first quadrant. So this is the negative 300, negative 300, and the positive 60. So this is 60. They have the exact same ratios, and then they all have the exact same reference angle. You can see both these have the reference angle theta r equal to 60, and the earlier one you can see so in this case the reference angle is again 60. So you can see theta r again 60. Yeah? So all of them has a same reference angle. So that's why, so if they are coterminal, they have the exact same ratios. Okay, now since we know all the theories behind, so we can actually find several trigonometric values. So we're gonna first write this ASTC, because that's very important. ASTC. So let's start with the first one. Let's try to find the cosine 120. Just to help you to get a help, so we can think of the angle. So it is in the second quadrant, so that's the angle 120, and then we're going to think of the angle closest to it, that's 180. So the gap is 60, so that means that's a reference angle. Okay, now what the theory says, this angle is in the second quadrant, which is a cosine. So according to ASTC argument, this has to be a negative one. So it's a negative cosine the reference angle. That's it. That's what the theory says. Now what we're going to do, we're going to plug in the values. So we know that negative, from the common value table, cosine 60 is 1/2 exactly. So that means this one has to be, cosine 120 has to be negative 1/2. So very simple. So part B, let's do sine 2 pi over 3. So let's try to find where this angle is. So so we know that the pi is 180, pi over 3 is 60, times 2 is 120. So that means this is again exact same angle that we just discussed. But since this is in radian, we know what's the reference angle. That's the reference angle. So that's the angle. So the reference angle is simply pi over 3. This angle is in the second quadrant, which is a sine. According to ASTC, there should be sine is plus, and then sine the reference angle, which is pi over 3. Again, according to the table, we know that sine pi over 3 is square root 3 over 2. So we're going to plug in this value. So it's going to be square root 3 over 2. So that's the exact value of this one. And then C. So next we do cosine 240. So we have cosine 240, and you can see this is more than 180 and less than 270. So that means this is in the third quadrant. So angle is in the third quadrant, that is 240. Angle closest to is 180. Gap between the two is 60. So that's a reference angle, 60. So and then according to ASTC, since this is in the third quadrant and which is a cosine, so that means the sign has to be negative. Negative cosine the reference is 60, and then you can see that it is negative 1/2 again. So let's look at this one, D. how about tan negative 5 pi over 4? We already know what is the reference angle. It's pi over 4. Only thing is we need to know what quadrant is this. So, and this is a negative angle. And if it was 4 pi over 4, it is pi, but this is 5. That means the angle goes to the second quadrant. So that's the angle. So this is a negative 5 pi over 4. And we already know the reference angle is pi over 4. So that means this is a tan in the second quadrant. So that means it has to be negative. Tan, the reference angle, pi over 4. From the common value table, we know that tan pi over 4 is 1. That means this is simply negative 1. So let's do a few more. And you can see that it's very simple. We need to find where the angle is. That's going to give you the sign. And then look at the reference angle. And then we can find the value from the table. As the next one, we're going to find sine negative 240. So again, so you can see this angle is in the second quadrant. So this is in the second quadrant. So that's the angle. This is negative 240. So we're going to compare this with negative 180. So the reference angle is going to be 60. So that means according to ASTC, this is a sine in the second quadrant. So that means it has to be positive. Sine, the reference angle is 60. So sine 60 is, we know that it is square root 3 over 2. Good. Let's go to the next one. So let's do next one. Secant 13 pi over 4. So this is in radian. So we know the reference angle is pi over 4. So let's see where this angle is. So we can look at the multiples of 4 for that. And so it is 0, 4, and 8, 12, so 13. That means in the third quadrant. So that's the angle. So so we have 0, 4, 8, 12, 13. So that's the angle. And you're going to compare with 12. So the gap is 1. So it is pi over 4. That we already know. And then this is a secant. Secant means it's like cosine. It's in the third quadrant. So it is negative. So that's a negative. So you can write, actually what we can do for this problem is you can first write this one as 1 over cosine 13 pi over 4, and then we can do the sign. So that we can do, so that means 1 over, and then we know that is a negative cosine, the reference angle is pi over 4. So if you plug in, so this is negative, so 1 over pi over 4 means 1 over square root 2. So since this is 1 over 1 over, when you multiply the top and bottom by square root 2, you're going to get negative square root 2, because you multiply the top and bottom by square root 2. Okay, so let's do the next one, G. So how about we do something like cosecant negative 5 pi over 2. So you can see that this is a multiple of pi over 2. That means we're going to use the unit circle for that. So this is secant. Secant means it is 1 over the y coordinate. So the 1 over the y coordinate. So you can look at the unit circle and see where this angle is. So this is the unit circle. So this is negative, and then so it's 5 pi over 4. So 5 pi over 4. So you can see, you can count. So you're gonna go. So we have a 0, and we have 1 pi. So this is 2, and then 3, and then this is 4, and then so you're gonna go one more cycle. So that means So you can, so this is 4 and 5, so that's there. So that means the point that we need is 0, -1. So this is the cosecant, that means in the y coordinate, so that means it's gonna be 1 over y coordinate, so that means 1 over -1, which is -1. So we're gonna calculate it like that. Okay, and then as the last one, let's try to find cotangent -390. So we can again look at the where the angle is, so we can draw the angle again. So this is a negative, that means it's gonna go clockwise. So you can see it is 0, 180, 360, 390. So it's there. So that means the angle is over here. That's the angle. So this is -390. You're gonna compare this one with -360. So the angle is 30. 30 degrees, always positive. Reference angle is always positive. So, and it's in the fourth quadrant, which is a cotangent. That means it's going to be a negative. So it's going to be, you can see that this is negative, and then this is a cotangent. So this is 1 over the reference angle, which is tan 30. So you can do that negative 1 over tan 30 means 1 over square root 3. So it is 1 over 1 over, so it's going to be negative square root 3. Okay, that's how you can find those in like pretty much any angle of the multiples of 30, 45 and 60, or multiples of pi over 6, pi over 4 and pi over 3. And then we also know that if it is in simplified radian version, and you can easily find the reference angle. If it's in degrees, the best thing would be you need to think about multiples of 180, like 0, 180, 360, 540, like that. Okay, now to practice what we learned, you can try these problems, and you can find you can leave your answers as comment, and then also if you need to check, you can ask those questions in the comment section. Thank you. I hope you learn how to find any value of trigonometric functions.